Oh, so we finally get to, I guess, kind of the point of factoring all these polynomials. It's one of the main points is to solve equations. So we've been able to solve linear equations. Now we can solve higher degree equations, and we do them by factoring. So just some vocab. An equation that can be written in the form some polynomial equals 0 is a polynomial equation. So you might think, what, 0? Well, just it can be written in that form, and you're going to see in a second how important it is for us to actually write it in that form. So in an equation like that, the highest power you see is the degree of an equation. So remember, to be a polynomial, all the powers have to be whole numbers. So if the biggest one of those you see in there is an x to the 7th, then that's a 7th degree polynomial equation. You're not going to see that in this class. But that just allows us to distinguish between different kinds. Sure. So if you see that, so let's notice a couple things. 3 is the biggest power you see, right? So it's a third degree. Or you could call it a cubic equation if you wanted. Notice that it's not written in the form a polynomial equals 0, but it could be, because you could very easily take this 3x and this 18 and subtract them off the other side. So they're not always going to be presented to you in that form. Sometimes you have to make it so. Here is a deceptively simple but incredibly powerful principle of algebra that we haven't really had to use yet in this course. It's called the property of zero products. So this, I cannot stress if you go further in mathematics how important this principle is and how powerful it is. This is probably the #1 most powerful tool we have for solving equations. Doesn't seem like much, but it is. So this is what it says, and it's easy to see that it's true. If a times b equals 0, then we only have two possible things that can be. Either a is b0 or b is 0, or both. The word or in math actually allows for both to be true. So obviously if they're both 0, then the product is 0. But if one of them is 0 and one of them is some other thing, then the product is still 0. So it's really important to note that 0 is the only number like that. That's why it gets its own property. If a times b is 10, you don't actually know anything about a and b. They could be 2 and 5. They could be -2 and -5. They could be 1 and 10. They could be a half and 20. You see what I'm getting at? There's an infinite amount of things that could be. So we get no information from that. It's useless. But if a times b is 0, we get a lot of information from that. We get this. We get either a has to be 0 or b has to be 0, and we have to account for both possibilities. Okay, so again, I don't want you to think of it as something you have to memorize verbatim. Just you're going to be using this property a lot, principal, property, whatever. So you'll see. Let's get into it. Here's a problem that's kind of already been factored. I just want you to see the property in action. So solve the equation x minus 6 times 4x minus 3 equals 0. Okay. Well, we have a thing times a thing. So our a is x minus 6 and our b is 4x minus 3. So the only way for this to be true is if x minus 6 is 0 or if 4x minus 3 is 0. So it's like we have two possibilities, so they kind of split apart into two little mini equations now. All right, so one of those things has to be true, and obviously they could both be true as well. Which, whatever, for your purposes, you just have to solve those two equations. This first one, x minus 6 equals 0, you can solve without even doing anything. X is 6, right? The second one, well, you have to do a little bit of a thing. So it's like your initial problem broke down into two little easily solvable mini problems. So either x is 6 or 4x equals 3. And for the second one, now you just have to say x is 3/4. Okay, so now both of those solutions work. This may be the first time we've seen in this course that an equation can have more than one solution, and in general, they will. These kind will. Not always, but most of the time they will. Okay, so if x is 6 or x is 3/4, this is right. So you can just literally write x equals 6, x equals 3/4. We list them out with a comma. We do that. So it means the same thing. It means x could be 6 or x could be 3/4, and this equation would be true. And look at back at the beginning at the original problem, and you can just look at it and see if that's true. If x is 6, this is 0, so this whole thing is 0. If x is 3/4, we have 4 times 3/4, which is 3 minus 3, so this thing is 0, which means this whole thing is 0, and nothing else. There's nothing else it could possibly be. Okay, so once you've solved those two little mini equations, you have it. So this has two solutions, and we have found them all. Primarily, we will be dealing with quadratic equations. You could also just call this a second degree equation. So we've seen the word quadratic refers to things being squared. Maybe a little misleading because quad usually means 4. Okay, so that's important. If you've ever seen the quadratic formula in a math class before, some of you are having PTSD from when you had to memorize x equals negative b plus or minus squared or b squared minus 4ac, right, over 2a. We're not going to do that in this class. But that's where these come in. And these come up in like a lot of applications in the real world, like more than you even think. Stuff having to deal with gravity and trajectories, stuff having to deal with like a revenue cost models and stuff. They're actually extremely prevalent. So we spend a lot of time on them in an Algebra 1 class. Right, and if you write it like this, if it comes to you in some other form and then you rearrange it in this form, that's called standard form. So where it's just ax squared plus bx plus c equals 0. So from now when I say put it in standard form, that's what I mean. Make it look like that. Okay, so here we go. We're solving our first polynomial equation from scratch. Solve x squared plus 3x equals negative 2. Now your temptation might be to look at this expression on the left here and say, oh, I could factor that. I could factor an x out of that. And that's true. You could. But don't, because that's not how it works. It wouldn't help you any. So when you see something like this, always put it in standard form. And really for the rest of the class, every polynomial equation you see, you're going to set equal to 0 if it's not already. Okay, so always, until somebody later on tells you otherwise, always set polynomial equations equal to 0. We only give it to you like this, so we force you to remember to do that, right? I could have just as easily, started with this. Okay, so now you have a quadratic equation equals 0, and now you can factor. So you're looking at that left-hand side, you're already doing it in your head. You're already starting to factor x squared plus 3x plus 2. It's a pretty easy one to factor. That's a good math term. It's more just like a lazy math teacher shorthand. We spend a lot of time saying left-hand side or right-hand side. So from now on, if I say LHS or RHS, you'll know what I mean. If you didn't, it'd be probably pretty easy to figure out from context. So factor that. It's going to be plus something, but 2's prime, so it has to be x plus 2 times x plus 1, which gives you the 3x in the middle. Boom. So that one didn't have a lot of possibilities for what it could possibly be. Okay, and now property of zero products. For this statement to be true, we have to either have x plus 1 is 0 or x plus 2 is 0. For x plus 1 to be 0, x just has to be negative 1. If you could solve that in your head, great. For x plus 2 to be 0, well, x has to be negative 2. There you go. So, again, they both work. I do want you to check them in the original thing. So this equation has two solutions. You might notice some pleasingness here where, oh, a second degree polynomial equation has two solutions. Two. Yeah, that's kind of how it works. So I would check it. I would list them out with a comma. I'm not going to mark it wrong if you write x equals negative 1, x equals negative 2. It's just, we usually see, if in later classes, you'll see equations that have 5, 6, or even infinite solutions in trig. So we just separate them with commas. And then I would encourage you to go back. You can go back to here, or you can go back to here, and just check them. Is negative 1 squared plus 3 times negative 1 negative 2? Actually, yes, it is. And it works with negative 2 as well. So equations like this are nice because you can always check your answer. So we're just going to keep making it a little more difficult. 2x squared minus 3x minus 7 equals 2x plus 5. Once again, when you see something like this, you say, oh, this is a polynomial equation, and we're in the chapter on polynomial equations anyway, so you know it. So get everything on one side, okay? So go subtract the 2x and the 5 from the left-hand side. That's the easiest way to do it. Okay, there it is in standard form. Obviously now combine like terms. If you are comfortable skipping that step, go ahead. We get 2x squared minus 5x minus 12 equals 0. Okay, so now we're back on factoring terms. You say, okay, is there a greatest common factor? No, there's not. So now you just have to factor it. So this is one of the kind where a is not 1. So, but you know that it has to be 2x something, 1x something, because 2 is prime. So we're just using the kind of guess and check method. So now, 12 kind of has a lot of factors. So go ahead and pause the video if you want and do this your own way. You need to be able to do this. Once again, I kind of just look at it until I figure out how to get that 5 in the middle. So it's got to be plus something minus some other thing. So I think if you put a 4 over here, that'd give you an 8. And then if you put a 3 here, that could bring you back up to the minus 5. There you go. So minus 4 gives you a minus 8x, and then plus 3x gives you a minus 5x. Boom. And then you get a minus 12. Okay, so obviously you're not done. It's just a means to an end. So now you have to solve the equations 2x plus 3 equals 0 and x minus 4 equals 0. Which you know how. So the first one is just going to be what? Negative 3 halves. So you can kind of do them at the same time. You can put them in 2 little parallel tracks like that. Or however. Okay, so you have x being negative 3 halves or x being 4. And that's it. It's true. Those are the 2 solutions to the original equation. Okay, so both of those numbers, if you plugged them in here, which I would encourage you to, would be correct. So just list them out. Okay, we're just going to keep getting more and more advanced here. Notice these are all quadratics. I'm not doing anything higher degree yet. Well, it's hard to tell here. So this is misleading because it looks like a fully factored thing on this side equals 7. But everything I've said so far holds. This doesn't, you can't do anything with this. You have to make it look like ax squared plus bx plus c equals 0. In other words, it's easy mistake to make would be saying, okay, this times this equals 7. So does that mean like one of them has to equal 1 and one of them has to equal 7? No. A million times no. It does not work like that. 0 is the only number that has a principal associated with it like this, okay? So it's all jumbled up as it is now, and we got to mess with it, but you have to make it look like you have to put it in standard form. Okay, so 0 is the only number like that. There's no any other number products property. Okay, so and this is purposely misleading to make you think that, but just think you do the same thing every time. So you're gonna have to FOIL this out. So that's what it is. It's a 3x squared plus 5x plus 9x plus 15. Middle terms combine, and then just subtract the 7 from both sides. So you have 14x plus 8. Okay, and now we're back on our exactly where we were before. We have to factor this. You can use the grouping method. So then you do 3 times 8, and you start trying to come up with factors of 24, which wouldn't be that hard, and it's probably a good way to do this. Well, that actually would be trickier, wouldn't it? Okay, never mind. No, I think you have to do it my way. Yeah. No, you could do it that way. Never mind. Okay, so we need a 14 in the middle, so I think a 2 here and a 12 here. Well, no, hold on. Yeah, no, I'm sorry, 2 here, and no, a 4 here and a 2 here would do it. See, that's why it's guess and check. I'm just guessing. So 4 here and a 2 here would give you a 12x plus a 2x, which would be an 8. Perfect. All right, and then just keep going. That was the hard part. 3x plus 2 has to be 0, or x plus 4 has to be 0. All right, x is negative 2/3, or x equals negative 4. And just your final answer, you can just summarize everything and make a comma separated list. Okay, so that's a bit of a process, right? That there's no real quick way to do that. That takes some steps, probably more than anything we've done in this course. I want to give you a bunch of examples of these. Solve negative 2x squared plus 10x plus 48 equals 0. So right away, don't just start factoring. Be smart. Look for, well, for starters, we don't like the fact that this 2 is negative, right? So we're gonna factor out a negative because we always do that when the first term is negative. But what else are we gonna factor out? You got to look for a greatest common factor as well. You're making it a lot harder than it needs to be if you don't factor out the greatest common factor. So they're all even, so they all have a factor of 2. So just remember we're going to factor out a negative 2. Okay, so the first term is just going to be x squared left over, and then it's going to be like a negative 5x and a negative 24. Okay, and then factor what's in the parentheses any way you like. At this point, you know, we're factoring machines. I think this is a pretty easy one to guess and check because all you have to look for is 2 factors of 24 that are 5 apart. And there you go, spoiler, they're 8 and 3. So when we get to that spot in the video, if you want to do it yourself, just stop me and just do it and then keep going. Okay, so this is a little different because now we have this negative 2 out front. And the principle of zero product says, okay, if this times this equals 0, then one of them has to be 0, but negative 2 just can't be 0. So that's one way to think about it, just like we just kind of toss that out because it just can't be. You could also think about it as dividing both sides of the equation by negative 2 because 0 divided by negative 2 is still 0. Be careful, you can't divide by 0, but you can divide 0 by anything. So when you're solving equations, these constants that come out front actually do end up just going away. Okay, so those are our 2 little mini equations, and they're easy, right? It's either x is 8 or x is negative 3. One last one of these, so this is new. And I know there's some of these on the homework. I don't think I'm going to put this on the test, but it's something we've seen before. This is just kind of the most advanced form of factoring you get in this class. Okay. So solve 2x cubed plus 3x squared equals 8x plus 12. Notice a couple things. This is not a quadratic. Okay, it's technically called a cubic or a third degree. They don't all have names. So you can just say it's a third degree because that's the highest power you see. Doesn't matter. Set it equal to 0. So resist the temptation to start factoring now. You could factor something out of this side and out of this side, but it would absolutely get you nowhere. So don't do that. Set it equal to 0. I still say it a million more times. Right, so that's just a matter of subtracting the 8x and the 12 from the left-hand side, and I just did that in one step. So remember this? There's only one way we've ever seen to factor something that has 4 terms in it. It's a quadrinomial or whatever, and that's by grouping. So we take the first 2 terms and the last 2 terms, and we try to factor something out of each of those. So if you look at the first 2 terms, the most we can factor out of there is an x squared. And if you look at the second 2 terms, the most we can factor out of there is like a negative 4. You are actually going to factor a negative 4 out of there, not a positive 4. You'll see why. All right, so when we take the x squared out of the first 2 terms, we're left over with a 2x plus 3. And when we do it out of the next 2 terms, when we take the negative 4 out of the next 2 terms, we're left with a 2x plus 3. If you tried to take a regular 4 out of here, you'd get like negative 2x minus 3, which technically is a valid thing to do, but it doesn't get us where we need to be, which is grouping, because remember, this has to be the same factor that's left over once you do the factoring. Okay, so this is a little different. So now you factor this into x squared minus 4 times 2x plus 3. Review that. This is a little wilder. We've done this, but so now, okay, we have one factor of 2x plus 3, which is great. We could solve that. And we also have a factor of x squared minus 4. So it seems like we're not done, and that's true. So look at x squared minus 4. Does that factor? It does. So sometimes, like with a higher degree polynomial, we actually have to keep going. We can keep factoring. Right, and that's a special kind. You should have seen that. Okay, x is a perfect square, 4 is a perfect square. So you know how that factors. That factors into x plus 2 times x minus 2. That's the only way you can do it. And the key is that 4 is a perfect square. Okay, So we kept going, and well, we have three factors that are equal to 0, and now we're just back to the place where we can use the property of zero products. But except now we have three factors in our product. So we just have to set three things equal to 0 and solve. So this is going to give us x is -2. This is going to give us x is +2. This is going to give us something else. There's your -2. There's your +2. One little extra step for that one, but you get -3/2. So just list them out. X equals -2, 2, or -3/2. Notice something. We went up a degree, and all of a sudden we got more solutions. So that won't always happen. There is a hard and fast rule about this, but it comes later. We could just say a third degree. For now, just a third degree can have at most 3 solutions. That's the most it can have. Okay, the quadratic couldn't have that many, but it did happen here. All right, one more. I sort of teased that like quadratics appear a lot in physics. So here's the most basic example. That if you take like Calc 1 or whatever, you'll deal with this same sort of problem a lot, and you'll see this equation a lot. So bear with me. A ball is thrown upward from the top of a building 180 feet tall with an initial velocity of 32 feet per second. Okay, so you don't have to, I'm just going to show you how those numbers factor into the equation. This is not a physics course. We can't build this up. So you're standing on top of a building, you're standing on the very edge, and you have to throw it directly in the air, but you throw it somehow at 32 feet per second. So it goes up, and then it comes back down, and then it comes all the way, then it hits the ground. So it goes past you, then hits the ground. Okay. This equation gives its height at time t. So just write that down. It's -16t squared plus 32t plus 180. Don't worry about where I got it. We can't really get that stuff until Calc 2. But the 32 comes from the velocity, and the 180 came from the height of the building. So there you go. As far as where I got the -16, that is intrinsic to Earth's gravity. So I didn't get that anywhere. That's just a simple fact of Earth's gravity. That number shows up in gravity equations because we live on Earth. Okay, so that I didn't get it anywhere. It's just, this is a true equation. This is right. Like, I didn't make this up. This is exactly what would happen if you went up to the roof and threw the ball or whatever. Okay? So its height above the ground at time t is given by this. I want you to find the time t at which the ball will be 192 feet above the ground. And I have a picture of it that will make this a little clearer. Okay? So we want to know at what time will the ball be 192 feet up. So you're at 180, you throw it up. Let's see what that looks like. It's a little misleading because this is time. So I said you threw the ball straight up in the air, and that's true. So it looks like a parabolic arc, which you may know if you throw things in real life. It is a parabolic arc. I don't know if I've used that word yet, but there you go. It's a quadratic. That's what the graph of them looks like. And so it looks like, okay, so this is time going by. So this is 1 second, 2 seconds, 3 seconds. It looks like at 4.5 seconds, the ball hits the ground. I didn't ask that. Maybe I should have, but I could. Okay, but I asked something a little different. So I asked when will it be 192 feet up, which is this dashed line. So notice it looks like you throw it up in the air and it passes 192 feet and goes a little higher and then comes back down. So I didn't really say it in the problem, but there's actually 2 times at which the ball is going to be 192 feet above the ground. Do you see that? Now, if you just look on the graph, you can kind of cheat. It's 0.5 and 1.5, but we're not going to cheat. We're going to do the problem, right? So to do that problem, we have to take this equation, the height equation, and we want to know when the height is at 192. So we have to set this equal to 192. And solve the equation. Okay. So obviously you don't have to remember that equation. I probably won't make you use it on a test, but you'll be given all this stuff. So again, pause the video, go ahead. There's nothing here we don't know how to do, and I'm going to kind of burn through the solution to it. So go for it. Set everything equal to 0. 180 minus 192 is -12. Look for the biggest GCF you can take out of there. You can't quite take a 16, but you can take a -4. So do that. You're left over with 4t squared minus 8t plus 3 equals 0, right? All the signs flip when you factor out a negative quantity. Factor what's in the parentheses. Do it however you want. This would maybe be a good candidate for grouping because you're just looking for, remember what you're looking for, factors of 12 that give you 8, except they both have to be negative. Right, because it's factors of 4 times 3. Whatever, I'm going to just do it. Well, I don't know. I'm just going to do it. So it's 2t and 2t. That's what it factors to. Right, you should have gotten this on your own anyways. So it factors to 2t minus 1 times 2t minus 3. And then we have to set 2t minus, so the negative 4, remember, doesn't really matter. It just kind of gets tossed out. 2t minus 1 is 0, or 2t minus 3 is 0. Solve those little mini equations. Maybe by this point you can do those in your head. We've done so many, so it's 1/2 or 3/2. Like that. Like I said, I like to do them on little parallel tracks like that. It's not that you're doing them at the same time, but so that's it. So like we said, so what did we just say? We said, okay, t is 1/2 a second, which bam, looks right, or t is 3/2, so 1.5 seconds. And I'm going to write them like that. All right, so at t equals 0.5 and t equals 1.5 seconds, that's when the ball will be exactly 192 feet off the ground. Okay, we're doing physics. Very fancy. Thank you.